Okay, let's talk about continuous. Okay, so to talk about continuous, like we have to talk about like 3 steps. Okay, so first one, like since we're gonna talk about like continuity at x equals 0, and we will talk about like that point. Okay, first one is that you must have function value at that point. If you do not have like that value, then what happens? It is empty hole or vertical asymptote. Does it make sense? Which is definitely discontinuous. Okay. The second case, second one is like your left limit must be equal to right limit. If they are not equal to each other, dun dun dun, it is definitely jump discontinuous. Okay. Number 3 is number 1, your number 2 must be equal to each other. What does that mean? Your function value is here. Your limit value is somewhere here, then it is definitely discontinuous, okay? So like we're gonna take here like these 3 steps for continuous, okay? Let's do it, okay? Here we go. So first step, function value. We must have f of 0, okay? So look at that. Like in your piecewise defined function, second part is defined at x equals 0, okay? So which equals 0. Oh, there is function value. That's fine, okay? Second one, we have to check the limit, okay? To talk about limit, we have to talk about left limit and right limit separately, okay? Here we go. Left limit. So which means x getting opposed to 0 from left-hand side with the function, okay? As we practice a lot, this means your x is less than 0. In other words, we have to use the first function of your piecewise defined function, okay? It is equal to limit x goes to 0 minus with first one, cosine x, okay? We can evaluate this one by plugging in, right? Cosine 0, which is equal to 1. Is it okay? What about right limit? Which means x goes to 0, but like this case, from the right-hand side, okay? As we discussed about this one before, that means x is bigger than 0. In other words, we're going to use like third equation of your piecewise defined function, okay? So that is equal to limit x goes to 0 plus with 1 minus x squared. Again, we can evaluate this one by plugging in 0 and equal to 1 minus 0 squared, which is equal to 1. Ooh, they are equal to each other. Then I can say there is limit at x equal to 0, okay, which is 1. But wait a minute, there's some problem, right? Look at that. Your function value is 0 and your limit value is equal to 1. Then it is against with number 3. Here we go. Let me state, okay? Here we go, number 3. Since your f of 0, which is 0, and your limit at 0, which is equal to 1, so are not equal to each other, then we can say your function f is not continuous at x equals 0. Does it make sense?